Welcome to your second lesson on writing equations for lines. We're going to go through 5 examples today, which will give you more practice on how to write the equation for a line given its description. So in the first one, we see write the equation of the line that has a slope of 1/2 and passes through the point 1, 7. What I'd like you to do is label the given information. So we know that the slope is 1/2. So let's call that M. We also know that we're given a point 1, 7, and we can label that x1, y1. We always start with the point-slope form of the equation, which is y minus y1 equals m, and then parentheses x minus x1. And the only thing that we have to plug in is the slope and the point, which we're given. So we start by writing our equation. Y minus 7 equals 1/2 times x minus 1. Now, the order that you do things next is really important. We always have to do multiplication first. So we want to distribute the 1/2. So on the left-hand side, we just bring down the y minus 7. And on the right-hand side, we distribute the 1/2. So we have 1/2 x minus 1/2. Next, we're going to add 7 to both sides. And we can only combine like terms, so we want to make sure we add the 7 to the number term. On the left-hand side, we have y equals 1/2 x. And then for the y-intercept, we're actually going to leave it as just a fraction. So it's like a negative 1/2 and a positive 7, which would give us 6.5. And that's our equation for our line. It's in slope-intercept form with the slope of 1/2 and the y-intercept of 6.5. Our next example, we're just given 2 points this time. And so now we're going to have to find the slope first. So we label our points x1, y1, and x2, y2. And then we recall the slope formula, which is m equals y2 minus y1 over x2 minus x1. And then we just plug in our points. So m equals 9 minus 9 over negative 4 minus 3. When we do the math, we end up with 0 divided by negative 7, which we know is 0. Now, hopefully this triggers your memory that a horizontal line has a slope of 0. So the points that we were given actually form a horizontal line. And from yesterday's lesson, we know that a horizontal line takes on the form y equals some number. So now we have to figure out what number would that be. And the clue comes from the ordered pairs. If you look at the y coordinates in both of your ordered pairs, they are exactly the same. They're equal to 9, which tells us that our line, all the y values have to be 9. So the equation is just y equals 9. Now, some of you maybe could have taken a shortcut on that and just bypassed the slope calculation. If you catch right away in your ordered pairs that the y coordinates are the same, you automatically know it's a horizontal line and you can just jump to your answer. All right, next example, we are again given 2 ordered pairs. So we will label them x1, y1 and x2, y2. And we'll start with our slope formula. So m equals, we're going to do 2 minus 7 over negative 1 minus a negative 1. Be a little bit careful with your negatives there. So in the numerator, 2 minus 7 gives us a negative 5. In the denominator, we can change the double negative to a plus, and we get 0. Now, negative 5 divided by 0, we can't do. That's an undefined answer. And again, hopefully you recall that a slope that is undefined is a vertical line. And again, from yesterday's lesson, we know that a vertical line has the equation x equals some number. You decide the number, again, based on the ordered pairs. And we notice that the x coordinates are identical. They're equal to negative 1. So our equation is x equals negative 1. And just like on the last one, if you notice your ordered pairs right away that the x coordinates are the same, you can jump right to the equation of the line. All right, example 4. Write the equation of the line where the x-intercept is 8 and the slope is 4. So the nice thing about this one is that we're given our slope right away, so we know that m is 4. But that x-intercept of 8 can be a little bit tricky. What that's really giving us is an ordered pair, where the x-coordinate is 8 and the y-coordinate is 0, if you remember that about intercepts. So what we're given is our x1, y1. So we go back to point slope form. Y minus y1 equals m times the quantity x minus x1. And we plug in our point and we plug in our slope. So we have y minus 0 equals 4 times x minus 8. So you bring down the y minus 0. We distribute the 4. So we have 4x minus 32. And then at this point, some of you are going to want to add 0 to both sides, which doesn't really change anything, so you can also just drop the 0. And we have y equals 4x minus 32, which is slope-intercept form, where the slope is 4, and the y-intercept is negative 32. All right, our last one is a little bit different. We aren't given any information other than the graph. We don't actually have to start with point slope form in this case. What we can start with is y equals mx plus b. Because remember, that's our end goal anyway, where we want the slope and we want the y-intercept. So m is our slope and b is our y-intercept. And we can pull that information right off of the graph. So let's actually look for two nice points, and they are marked here. So that's good. So you can pick any two nice points, and we'll do the rise over the run. So if we start at 0, 3, we'll go up 2 and over 1. So our slope is 2, which you can write as 2 over 1. Our y-intercept is where the line crosses the y-axis. The x-coordinate is 0, and the y-coordinate is wherever that line crosses that y-axis, which we can see here is 3. So our b value is actually just 3. So when we plug in our slope, we're going to replace m with 2. And when we plug in our y-intercept, we're going to replace b with 3. And there's our equation. You can now move on to the next practice lesson for writing equations.